Alright, so today we're going to be talking about geometric sequences. So remember, arithmetic sequences, we either added or subtracted by the same number every time to get from one term to the next. So a geometric sequence just means that we are going to be multiplying by a number to get from one term to the next. So a good example of that is bouncing a ball. So you can see the height on the initial drop, and then the first bounce, second bounce, third bounce, fourth bounce. So we can describe that, that gives us that the ratio is 60%. So we could just multiply 3 by 0.6, and that would give us our first height, and then multiply that by 0.6, and that would give us the second height. So these have a common ratio, not a common difference. So the common ratio is just what we're multiplying by every single time to get from one term to the next. So if we look here, notice we're still going to denote them the same, like a sub 1 is our first term, a sub 2 second term, a sub 3 is our third term. But now, if we want to find what the common ratio is, we use this formula here. And all that's saying is that we take a term and we divide it by the previous term. So in this situation, we would want to take maybe a sub 3 on top and divide it by a sub 2 on bottom. And that would give us our common ratio. So take a second and see if you can figure this one out. Alright, so hopefully you took one term and divided it by the previous term. So do 20 divided by 8, 50 divided by 20, 125 divided by 50. Notice we get a ratio of 2.5 for all of them. So that means if we need to find the next term, all we have to do is multiply 125 by 2.5. And that would give us D. Alright, so this is the formula for a geometric sequence. Again, it's on your cheat sheet as well. So it's a sub n, so the term we're looking for, is equal to the first term times the common ratio to the n minus 1 power. So let's take a look at this example here. We know the first term is negative 3, and our common ratio is a negative 2. And we want to find the eighth term. So that means we're going to plug in a sub 8 is equal to the first term, which is a negative 3, times negative 2 to the 8 minus 1 power. And if you're using a calculator, make sure you put that negative 2 in parentheses so you don't have any sign issues before you raise it to the power. So we just plug all that stuff in like I just said. And then we would end up with negative 2 to the 7th power, which would make a negative 128. So negative 3 times negative 128 is 384. So the eighth term is 384. So we should also be able to write an equation to represent the situation. So notice this geometric sequence is what we got: 3, 12, 48, 192. Hopefully you guys can look at this right away and go, I know what the common ratio is, because if we take 12 divided by 3, we get 4. So we know we're multiplying by 4 every time to get from one term to the next. So all we need to do here is just plug in the first term, which is a 3, and then our common ratio, which we already found to be 4. And that would be our equation. So now if we say we wanted to find the 10th term, we just plug 10 in for n and work it out. Alright, so we're going to try a little bit more challenging problem, because up to this point I think you guys think it's pretty easy. So notice we want to find the 10th term of the sequence where the fourth term is 108 and our common ratio is 3. So notice we need to find that first term because that's part of our formula. So what we can do here is plug in everything we know to our original formula. Don't worry about this over here. So we plug all that stuff in. We know that the answer to our fourth term would be 108. So we're going to put 108 here. And we know that R is 3. And we also know that the n value is 4 because the fourth term is 108. So we're going to plug in a 4 right there for n. And then we can do 4 minus 1, which is 3. 3 to the third power is 27. So we'd have 108 equals 27 times a sub 1. So now all we got to do is divide both sides by 27. And we get the first term as 4. Hopefully you might have realized that you could have just kept dividing 108 by 3 to get back to the first term as well. So now it wants us to find the 10th term. So now we're just going to do what we did in the previous slide. we're just going to plug in everything we know. We know the first term is a 4. We know our common ratio is a 3. And we're trying to find a 10th term. So we plug in a 10 for n. And then a calculator would be a great tool for this because these numbers can grow very fast in geometric sequence. Think about the COVID-19 virus. Think about the growth pattern of that. Exponential in its growth, just like geometric sequence. Alright, so the last type of problem is doing the geometric mean, so finding the missing terms. So these are a little bit more challenging than finding the arithmetic means. So notice our first term here is 2.25, and then our fifth term here is 576. So what we're going to do is just plug in everything we know. So I'm just going to jump it down to here. And we know the first term is 2.25. We know the fifth term is 576, so we plug in the 5 there for n, and we know that a sub 5 is 576. So now we need to divide both sides by 200. Divide everything by 2.25. And we get 256 equals r to the fourth. So now if we take the fourth root, remember we take even roots, we have to put plus and minus in front of our solution. So really this one's saying we could have two different solutions. A positive 4 is our common ratio, or negative 4 is our common ratio. So if the ratio is negative 4, it would have an alternating pattern of positive, negative, positive, negative, positive. And then if it was just positive, all the numbers would be positive. But for our purposes, we're just going to assume they're positive. So all we'd have to do now is take 2.25 and multiply it by 4. And we would get 9, so that would be our second term. And then we take 9 times 4, we get 36. There's our third term. And we take 36 times 4, and we get 144. So that would be our fourth term, and that's what we were missing in the original problem. All right, so if you guys have any questions, feel free to shoot me a message. Hopefully, this is a nice, easy lesson to kind of get us back into the swing of things after spring break. Have a great day.